To classes by Inspire Physics. Today we are going to see a few applications of Kirchhoff's rules. Now here we can see two diagrams. This is one network and this is another one. See, for this network we can see there are resistors. See, we have two cells, 8 volt cell positive and this is negative, 3 volt cell here positive and this is negative. Now it is connected like this. We have the cell in the branch A, B, we have the cell. Let 0.2 ampere be the current. See, in the question, it is given that 0.2 ampere is a current flowing. So 0.2 ampere is a current from the positive of the cell. Okay. Now we have a few resistors connected like this. Here in this branch, in this mesh B, C, D, E, B, there is no other cell. Okay. So we can find equivalent resistance of these 4 resistors. 5 ohm, 10 ohm, then 10 ohm and 30 ohm. All these connected. See, 5 ohm and 10 ohm are in series. 5 and 10 in series. Then this 10 ohm is parallel to this series combination. This is again parallel to this 30 ohm across the points B and E. Okay, first we will reduce this. We will simplify this. Now we can simplify like this. We have a B across B and D, 5 ohm and 10 ohm in series. What is effective value? 5 plus 10, 15 ohms. So we have 15 ohms. Okay, 15 ohms. Then this 10 ohm and this 30 ohm. All are connected in parallel. These three in parallel. How will you simplify? We can say 1 by Rp is equal to 1 by 15 plus 1 by 10 plus 1 by 30. We'll take LCM. LCM will take 30. Out of 30, here we'll have 2. Here we have a 3. Here we have 1. You'll get 6 by 30. So what is Rp? Rp is equal to 30 by 6. We'll get 5 ohms. Okay. So instead of these resistors, across the points B and D, we have a single resistor having a value 5 ohm. So no need to draw these resistors in next diagram. In next diagram, across B and D, we have only one resistor, that is 5 ohm. And what is the remaining components in this network? See, we have the cell of 8 volt. Then we have across B and D 5 ohm resistor. Here we have an unknown resistor, capital R. Here we have another cell of 3 volt, 15 ohm resistor. See, current flowing in the circuit is 0.2 ampere. So this is 8 volt cell, this is 3 volt cell. So the combination of these two cells is providing a current. What's the value of current? Current is 0.2 amperes. So this combination is providing a current 0.2 amperes. This current flow like this. Okay, in the closed network. This is a direction of current. From positive of the 8 volt cell, the current flows through the 5 ohm resistor across B and E. Then it flows like this through the unknown resistor. Then it flows up along with the cell. Okay, 15 ohms, it moves like this. This is a direction of current. Okay, now we will apply Kirchhoff's rule. So what's our aim? We need to find the value of unknown resistance as well as the voltage between, potential difference between B and E. Okay, that you can easily find, potential difference between B and E. Voltage across B and E is equal to current into resistance. Resistance is 5 ohm. What is the current in this branch? See, current in this branch already given in question, it is 0.2 amperes. So we can say voltage across B and E is equal to 0.2 is a current. Resistance is 5 ohms. 0.2 into 5. 0.2 into 5, what will be the value? 1 volt. 1 volt will be the voltage across B and E. Now we need to find the value of unknown resistance. We need to apply Kirchhoff's rule. Like we apply Kirchhoff's mesh rule. So in mesh rule, we can see that we start from end A. From end A to B, we have a cell. We traverse in clockwise direction like this. Okay. From end A to B, we have minus to plus. So we write plus 8 volt. Then we come like this, same direction. We traverse like this. Current also same direction. We put a negative. What is the voltage here? 5 into 0.2. We know 5 into 0.2. Okay. Then we come through this resistor. Current is the same 0.2 ampere. Resistance is R. We can write minus, same direction. We traverse like this. Current also same direction. We put negative minus 0.2 into R. Okay. Then we come upwards like this. We come, we just move like this. Positive to negative. So we will put negative voltage, negative 3. Okay. Now we come upwards. Here also direction of traversing and current in same direction. So we will put a minus. 0.2 is the current. Then resistance is 15. We can write 0.2 into 15. Okay. And that will be equal to 0. How will you simplify this? 8 for 5 into 0.2 is 1 minus 1. Then we will take minus 0.2 R minus 3. 0.2 into 15 is it will be 3, that's minus 3 is equal to 0. Okay, 8 minus 1 is 7, minus 3 minus 6, 7 minus 6 minus 0.2 R is equal to 0. Taking this to right side, 7 minus 6 is 1. 1 is equal to 0.2 R. What is R? R is equal to 1 by 0.2. This is 5 ohms. So, we got the value of R, that is 5 ohms. So, we got the value of capital R as well as potential difference between B and E. What's the value? It will be 1 volt. 1 volt is a potential difference between B and the terminals B and E. Okay. Now we go to the next problem. So likewise we have one more problem. See, in this diagram we have a 4 volt cell. Okay. A 4 volt cell is giving a current I1. This current flow like this. This current come to the junction. This 6 volt cell giving a current I2. This also coming to this junction. At a junction they combine. See, here we have 4 ohm resistor. Through 4 ohm the current I2 flows. This current I1 directly comes to the point. They will combine here. They combine I1 plus I2 flow through the resistor 8 ohm. It reaches to the junction. So I1 is the current from positive of the cell. At the negative the current reaching should be I1. So this current should be I1. So current I1 flow like this to the negative. So I1 flows through the 6 ohm as well as the 2 ohm. Now I2. See, I2 from positive of the cell, I2 is the current leaving. So current entering in the negative of the negative terminal of the 6 volt cell should also be I2. So this current should be I2. See, the current I1 plus I2 split as I1 flow in this direction, I2 flow in this direction. So what's our question? We need to calculate the potential difference across the 8 ohm resistor. So we need to find the voltage across 8 ohm. We need to find I1 and I2. So to apply Kirchhoff's law, we take a loop A, B, C, D, A. A, B, C, D, A. In this loop, we start from the cell, like as we traverse. We traverse in clockwise direction like this, clockwise direction, plus to minus. We can take the voltage minus 4. Okay, then 2. So we move like this. Current is in opposite direction. We put a positive sign. 2 into I1. Okay, 2 I1. Again we traverse like this. Current is against us. So we take a positive sign. Then 6 into I1. Okay, now we just come like this. See, we come in this direction. Current is against us. Again we take a positive sign. 8 ohm. This is the current. I1 plus I2. See, 8 I1. 8 into I1 plus I2. I1 plus I2. Then we just come like this. So there is no other component. It will be equal to 0. How will you rearrange this? 2I1 plus 6I1 plus 8I1. 2 plus 6, 8. 8 plus 8, 16I1. 8I2 plus 8I2 is equal to minus 4. We take to right side. It will be equal to 4. Okay. So I just divide throughout by 4. When dividing throughout by 4, we will get 4I1 plus 2I2 is equal to 1. We can take equation number 1. Okay, we have got first equation. 4I1 plus 2I2 is equal to 1. Now we move to the next loop, DCEFD. DCEFD. So in this, we start like from D to C. We just move like this, clockwise. We move in the clockwise direction. Current also in the same direction. We take negative. Minus of resistance is 8. Minus 8 into, what is the current? I1 plus I2 is the current. Okay. Then we come like this. Current is in same direction. We just move like this. So we just give minus 1 into I2. We can say minus I2. Again we come from negative to positive of the cell. We can say plus 6. Okay. Here also we move in the same direction of current like this. So current is I2, voltage is, resistance is 4. Same direction we put again negative symbol, minus 4I2. 4I2 is equal to 0. Now rearranging, we have only minus 8I1 Okay, minus 8 I1. How many I2? Minus I2, minus 8 I2. See, minus 8. So both will be minus. We can say minus 9 I2. Okay. So we have one more I2. Minus 8 I2, minus I2, minus 9 I2, minus 4 I2. Minus 13 I2 we have. Minus 13 I2. This 6 I take to right side. Plus 6 becomes minus 6. Dividing throughout by minus, what will you get? Minus 1. You will get 8 I1 plus 13 I2 is equal to 6. Equation number we will put later. Here we have 8 I1. Here we have 4 I1. We need to make this 8 I1. How can you make 8 I1? Multiplying equation number 1. We need to multiply 2. Multiplying 2 with equation number 1. We will get 2 I1. Okay. Plus, sorry. 2 when you multiply, you will get 8 I1. 2 into 2, 4 I2 is equal to 2. This I put equation number 2. This I put equation number 3. We have got the 3 equations. Equation 1, 2 and 3. So 2 minus 3 we will subtract. When you subtract 2 minus 3, what will you get? When you subtract 2 minus 3, 8 I1 minus 8 1 is 0. 4 I2 minus 13 I2 is minus 9 I2. Okay. 4 minus 13, 9. Minus 9 I2. Minus 9 I2 is equal to 2 minus 6 is minus 4. Okay, so what is I2? I2 is equal to 4 by 9. I2 have got 4 by 9. Then we need to find I1. How will you find I1? See, here we have 4 I1 is equal to, see, take the equation number 1. 4 I1 is equal to, 4 I1 is equal to 1 minus 2 I2. 1 minus 2 I2. What is I2? 4 by 9. 2 into 4 by 9. That is 1 minus 8 by 9. What is 1 minus 8 by 9? When you simplify, you will get 1 by 9. 4 I1 is equal to 1 by 9. So what is I1? I1 is equal to 1 by, see, 4 I1 is equal to 1 by 9. What is I1? I1 is equal to 1 by 4 into 9, 36. This is I1. Okay, now I need the sum of these two because I need to find the current through 8 ohm. How will you find the sum? See, I1 plus I2. I1 plus I2 is equal to, we have 1 by 36 plus 4 by 9. See, how can you make the denominator 36? Multiplying a 4 here. On numerator as well as denominator, you will get 4 into 4 is 16. Numerator you multiply by 4, denominator also by 4, you will get 36. When you add, you will get 17 by 36. This is the total current I. See, this is the total current flowing through the resistance 8 ohm. So we need to find the potential difference across 8 ohm. What is the potential difference? See, V is equal to, we know that voltage is equal to the total current I into the resistance. I means 17 by 36. What is the resistance? 8 ohm. This is the resistance. See, when you simplify, you can get 2 times 9. Okay, you will get 34 divided by 9 volt. This will be the voltage. Okay, this will be the voltage across the 8 ohm resistor. So hence we have simplified, solved these two questions. These two networks we have solved. We have calculated potential difference across 8 ohm resistor here. Here we got a value unknown resistor and we have found out what the voltage across B and E. Okay, I hope that you have understood. Thank you.